Dimensionality reduction in data science, machine learning. Okay. So, what is dimension? Means in machine learning, if we see any data, then data is a kind of noun, means it's an identity, and it has properties. So, we call property loosely as features. So, if there is an entity, there is a noun, then it has adjective, and it has properties, and one of the properties means whatever property a noun carries, one of them generally we say it is the target, it is the label, it is the class of the noun. So actually class is also a property. So if there is a n number of samples, so n number of nouns are there, and n into m features are there, then one of the feature we can say it is a class, or combination of few features we can say it is a class, means this is what I want, and the rest of the features would become kind of input feature, and one feature or combination of few features become class. That is the desired or output feature. So this is kind of the disassembly of the data in data science. Now, dimensionality reduction. So how we reduce the dimension. Dimension means number of features. Like if there is a person, so there is a person called John, his name is John, and he has features, means he belongs to a country called France, and his nationality is French. So he has two properties. One is name of the country and name of his nationality. Now, if I draw a circle, or in 3D if I draw a sphere and call it the noun, then it is John. So it's a person, it's a human entity, and it has two properties. One is country and one is nationality. So country is one axis of information and nationality is another axis of information. Like if I see 1D of any graph, then it is x-axis. If I say it is 2D graph, then it is x-axis and y-axis. And if I say it is 3D graph, then it is x-axis, y-axis and z-axis. So there are three axes. So like that we can consider that if there is a axis, there are two features, country name and nationality name, then there are two axes. So we know maximum 3D, but number of features, if there are 100, then we can call it as 100 dimension. Okay, so if there are two features, then it is 2D, and if there are 100 features, then it is 100D. Okay, dimensionality reduction is, can we reduce the dimension? If there are 100 features, certainly you know that if 2D graph, what difference between 2D and 3D? The complexity of 2D and complexity in 3D, it is 1,000 times more complex than 2D. Means it is one step up, but it is 1,000 times more complex. Just think about, if something has 1,000 features, 1,000 axes, then what would be the complexity to handle? Impossible. Means human brain cannot do that. Means computer would also do it. Program would be very complex, extremely. So if there is a noun and if there are properties, then that many properties means that many axes of the information exist. Can we reduce the number of axes? So if axis is 3, it is 3 dimensional. So if my graph is in x, y, z and 3 axes are there, then my graph is 3 dimensional. So if it is n dimensional, if it is m dimensional, m for monkey. So if it is m dimensional and number of nouns are n, N for news. So, if it is m dimensional, then can we bring it lower? So, that is dimensionality reduction. So, now if we see, so dimensionality reduction is nothing but how much information we are carrying. Of course, the way I say, electronics is game of resistance. So, if you understand the concept of resistance, you understand the electronics. Means there is nothing called impedance or capacitance and variable and this and that. When battery supplies the current, it just sees the resistance path. Wherever it finds the resistance, at that moment the lowest current flows through that path. Doesn't matter it is in complex number or imaginary number for the battery. Like what he says, the 3D, it's a game of vertices. In this machine learning or data science, it's a game of information. How much information one data set carries? If it is 1000 axis, doesn't matter. Means how much information it is carrying. So, if a country is France, then certainly his nationality will be French. There is no extra information. Okay? Like that, France, French, and then he like French food, and he like to go to Paris. And if these are the axes, and into 100 axes, if I define, doesn't matter. Information is in one axis only. 99 axes are waste. So, the net information lies in one axis only. So, can we do some mathematics that it would say that it would draw the net information and then everything falls in one axis. And 99 we can just we can cut down. So 99 axis we can take it out and any one axis we will keep it. That is dimensionality reduction. Means how much information we are carrying. Okay, so now a person named is John and he belongs to a country called France. His language is French. Not required that everyone in France speaks French. Everyone in France is of French origin. Means more or less we can say. His nationality is French. A person who is from Netherlands, a person who is from Switzerland, not necessarily he is speaking Swiss only, he may speak German also. So, now if I draw two axes, name of the country and name of the language, still there is common. Maximum chance is that a person living in Switzerland, he is speaking Swiss. Or less chance that he would speak German, but still there is intersection. If there is intersection, I would say the information is not multiplication. Means if one axis carries 10 information and one axis carries 10 information, net information is not 100. I cannot multiply. Okay. So that means it is not orthogonal. If two axes are not orthogonal, then there is chance of reduction. So can we find a new axis which carries the net information what these two axes are carrying? That is, we also there are ways, mathematical ways, like Ein vector and those things we calculate, where we try to find a new axis, new feature, hybrid feature, where both information, name of the country and the language they speak, both comes into the picture. And then we apply the mathematics on both the axes so that they map on the axis. If they map, then their component on that axis and their component on that axis comes into the picture. And with one axis only, we try to get the maximum information. So this is dimensionality reduction. So can we lower down the number of features? Can we lower down the number of axes? Can we lower down the number of dimensions so that net information it carries is almost same what it used to carry? Why there is dimension reduction? Because they are not orthogonal. If all the axes are orthogonal to each other, then there is no dimensionality reduction required. It's not possible. Means, can I give one example? Okay, let's consider the coloring. Okay, now I have a color called red and I have a color called yellow. So, yellow is nothing but combination of red and green. So, the information in red is also available in yellow. So, they are not orthogonal to each other. This proves that there is a chance of dimensionality reduction. What about red and green? Blue, red, green and blue. If I say name of color, so if there is a ball and it may be red, it may be green, it may be blue, and if I say red, green, blue are three different features, then these features are orthogonal to each other. If these features are orthogonal to each other, then there is a 90-degree angle. If there is a 90-degree angle, then cos 90 means the essence of one information on the other information, that is the cos theta, that is 0. So if try to find the red essence on green, 0. Green essence on blue, 0. Blue essence on red, 0. So if I have three colors, red, green and blue, then dimensionality reduction is not possible because all three are orthogonal to each other. If all three are orthogonal to each other, then that is the maximum information is possible. Means we cannot reduce it. But if I see that there is an axis called red, green, blue and yellow, then yellow we can take it its essence. We can find out yellow's essence. So yellow is generally mixture of red and green. How much red it has and how much green it has, that we will do cos theta and sin theta and place it on green and red and just yellow would vanish. So that much information we have along the red axis and green axis. So yellow axis we make it, means we just scrap. So this is dimensionality reduction. So dimensionality reduction is very clever thing. If we know how to map all the information into orthogonal information. I mean, it's not easy. I have millions of colors. How much information it is carrying? Three directions. That's it, red, green and blue. If I have all colors, possible colors, I can specify in these three axes only. So this is dimension. How nice it is. Rather than writing 40 million colors, in the combination of these three axes only, I am writing the colors. All possible directions, means judo, karate and this and that, whatever I am doing, all is possible in X, Y, Z vectors. So, but generally when we talk about nationality and language, it's not that easy to, so that is a mathematics. So this is dimensionality reduction. Means people are struggling at how we can do it.